Hello YouTube, this is Chirag from scratchbuilds.com and welcome to the part 2 of DIY FPV Ground Station. So in this video I'm gonna take the back cover of the monitor, show you guys inside how I have connected everything and what you need to solder, hot glue, drill or cut to make everything fit nice and snug inside the casing. But before we do that, let's take a look at the components we're gonna need to complete this build. Okay, so first in the list is of course our 7-inch monitor, the video receiver, and a 1000 mAh 2S Lipo battery, one GST-XH 3S female connector to be able to connect the external battery to the system, two of the SPDT switches, one for the entire system and one for the internal receiver, one GST-XH 2S female connector, GST-XH 2S male connector, and a JST male connector. So using these three connectors, we're going to make a cable to charge the internal battery of the system, which I totally forget to show how it works in the first video, but here's the cable. So as you can see, it has a GST-XH 2S female at the one end, 2S male at the other end, and also the JST male connected to the same end. What I've done here is it's connected to the two end pins, not the one in the center. And using this cable, you can charge the internal battery of your system just like any other 2S Lipo battery. The way this works is pretty simple. The female end connects to the balance charge lead coming out from the internal battery, and the other end of the cable goes to your balance port on your charger, and the JST will connect to the main inputs. So those were all the components we'll be needing. Apart from those, we will need some heatsink tubing to keep everything isolated. We're gonna need to do quite a bit of soldering, so a good solder and a soldering iron will require, super glue, double-sided sticky tape, and also a hot glue gun. Alright, so as you can see, these are the internals of my build. The left side is the front panel of the monitor, and this monitor circuit board, you may need to move it to the right so it's not in the way of your video receiver. So this is the back panel of the monitor, and this is where we have done the most of the modifications. So our video receiver is attached in the top right corner, and two holes are made, one for the dip switches and one for the antenna to stick out. And I have used the double-side tape to attach it to the back panel. Now the 2 cell you see here is from my Park Zone 1300 mAh battery. I had one puffy cell in there, so I carefully split all the cells and used the 2 good ones for my build. But if you plan to do something like this, please be very careful. And I cannot be held responsible if you hurt yourself or put something on fire. So as I mentioned in the first video, that there was a big crack at the bottom of the monitor, and the reason is this battery is too big to fit inside. As you can see, you should use about 1000 mAh battery, or the battery that is not longer than 3 centimeters, 30 millimeters. There's one more little modification to do with the battery, is we are only going to need the balance port, so we can remove or the desolder the main connectors of the battery, the main discharge port, and cut the hole in the back panel and just super glue the balance connector. Okay, so next to the battery on the left side, I have cut 3 holes, 2 for the switches and 1 for the 3S battery input. I'm not gonna go into the connection details right now, as I'll be showing you the connection diagram later in this video. Okay, so this is the main input that goes into the monitor circuit. It has 6 pins. From left it is power, ground, video 1, and then ground for the video 2, and we're not using the number 6. Okay, so from that connector, pin number 3, which is AV1, is connected to our video out 1 of the video receiver. As you can see, this yellow cable is soldered straight to the circuit board. And the pin 5, which is AV2, is extended here with the RCA female jack. All the extra cables that came with the monitor, I have taken one RCA female jack, removed the yellow plastic, and soldered the pin 5 wires to it, and just use the barrel and attach to the back panel. And while I was doing that, I had a real hard time to figure out how I can connect this metal barrel to this plastic, but thanks to my lovely wife, she gave me an idea that what I can do, I can use the heat shrink around the metal part and then just super glue it to the plastic. So that is exactly what I did, and as you can see, I also use a lot of hot glue to reinforce the connection. This is our receiver, the 8-channel receiver, and this is how it looks when you take it out of the metal casing it comes in. And this is the video out 1, and the empty spot you see where my thumb is the video out 2. Now I have carefully desoldered the 3.5mm connection over there so that I can do another output here at the bottom of the screen. And there's the hole at the bottom for the output, and as you can see, it's a tapered hole to get the perfect connection. And the female 3.5mm jack is simply super glued to the back panel, and then I use some hot glue around it to keep it secure. These 4 wires that coming out of there are ground, power, audio, and the video, and they are connected to the board. I have simply soldered them right on the board to their proper connection. This 5-volt linear regulator will get hot during the operation since it's stepping down 8 or 12 voltage to 5 voltage, but the way we have placed our receiver is right above those ventilation on the back, so that way it will help the system stay cool. Under those ventilation holes, I have drilled one more hole so that our LED can stick out of there and we can see if the receiver is turned on or off. I just eyeballed the position and drill a little hole. This LED is a little bit flexible, so you don't have to be exact. You can move it around a little bit. Okay, so as you can see, I have soldered all the wires behind the board and use quite a bit of hot glue over it to keep everything insulated, and also use some hot glue to reinforce the switches here. So that was all the hardware modification there is, and now let's move on to how I have wired up everything. So let me pull the wiring diagram for you guys. Okay, so I have drawn a little diagram here to explain the wiring I have done. So in the top right corner, that's the pin that goes into the LCD circuit board, and as you can see, it has 6 leads, power, ground, video 1 in, and then the ground for the video, and the video 2 input, and this pin is not connected. And to show you guys, this is the pin I was talking about. Back to the diagram, this is our video receiver. This is the power jack. This is the audio video 1 and out, and the audio video out 2. And here's the picture of the video receiver, but the receiver is turned upside down, so from left it's first is the power jack, and the 2 on the right are the video out, audio video out 1 and 2. Also, this picture was taken before I desoldered the AV2 jack to get the external video output. Alright, so let's move on to the switches that we used. They are both SPDT switches, single pole double throw. In the picture, our switch is in the right position. That means our center pin is connected to the right pin, and when we move it to the left, the center pin will connect to the left side pin. So that is how the SPDT switch works. I have drawn the other switch upside down so that I can easily show the connection between them. Moving on to the battery, in my build I have used a 2S Lipo. I have split the cells open and laid them flat like you can see in the picture. And if you decide to use your Lipo like that, please be very careful because it can be dangerous. Or just buy 2 separate cells from Hobby King. This is the 2S GST-XH male connector, the balance port to charge the internal battery, and this is the 3S GST-XH female connector to plug in the external 3S battery. We'll be using our receiver circuit board to ground everything, as it has many points where we can solder the ground wires. Okay, so let me quickly draw all these ground symbols so you know what should be grounded to complete the circuit. Alright, so let's start connecting everything. This battery is connected in series, so if you buy the two separate cells from Hobby King, you want to connect them like this to the JST male connector so that when you charge them they will be balanced. So this is our main power switch and this is the receiver switch. When the switch is in its off position, that side of the pin connects to the positive of the external battery, and when we flip the switch on its on position, that side of the pin should connect to the positive of the internal battery. Let me use the red marker over here to show you how the power is running in the system. So when we move the switch to its on position, we are connecting the center pin to the internal battery. From there, the center pin is connected to the power of the LCD screen and also to the center pin of the receiver switch. So by powering on the main switch, we are sending power to the LCD screen and also powering the receiver switch. And then to power our video receiver, connect the power to the receiver switch like so, and we're pretty much done. Now let's connect our video sources. So we have two video outs on the receiver, AV1 and AV2. The AV1 is internally connected to the video input 1 of the LCD like so. For this connection, I highly recommend using the wires that came with it. It's like a coax cable. It has a center pin and there's insulation around it, and around that insulation there's like this wire mesh. So the internal wire works for video and the external for ground. Makes it really easy to connect the video signal and to properly ground it. As you can see in the picture, the center wire, the yellow wire, is our video out 1 connected internally from receiver to the LCD screen. The video input 2 of the LCD is gonna connect to the RCA female jack, which will be mounted at the bottom of the monitor, and we're gonna simply modify the provided RCA female jacks for that. And these are the pictures for your reference. Also, a thumbs up for the wife's idea to use the heat shrink around the metal part of the RCA jack so that we can simply super glue it to the plastic body of the monitor. And now the last thing is to desolder the video out 2 from the receiver and extend it to the bottom of the monitor. This is a very useful feature if you want to expand your video to a bigger monitor, or use it as an input to your video goggles, or also simply connect to your DVR and record your flights. So thank you so much guys if you're still watching this video. I know it's kind of boring, but that's my best video editing skills there, and I just really hope that I was able to explain everything that I did. One thing still missing in this build is the Lipo alarm for the internal battery, but I'm working on using the batteries from the point and shoot cameras, as they are small in size and their capacity is like 4000 milliamp hours, so we can run our system for like 6 to 8 hours. But I'm not gonna promise you anything right now because it took me over a month to just get this video out there. But I would definitely like to hear from you guys. If you have any questions, comments, or suggestions for this build, please leave them in the comment section below. And as always, thank you so much for watching. This is Chirag from scratchbuilds.com.